Hi everybody, Mrs. Pesic here,
And Miss Bella here.
and we are looking at section 10.4, inverses of trig functions. The objectives are to evaluate inverse trig functions and to use trig equations and inverse trig functions to solve problems. Our vocabulary: inverse sine, inverse cosine, and inverse tangent. So you have evaluated trig functions for a given angle, and you can also find the measure of angles given the value of the trig function by using an inverse trig relation. So in this case, the sine of theta, if the sine of theta is equal to A, we can rewrite that, the inverse, by saying sine inverse of A equals theta. So for example, if the sine of pi over 4 is equal to square root of 2 over 2, we could say that the sine inverse of square root of 2 over 2 is equal to pi over 4. All right, likewise, if cosine of theta is equal to A, then the cosine inverse of A is going to be equal to theta. If the tangent of theta is equal to A, then the tangent inverse of A is equal to theta.
Again, just take a look at that reading math box, that the expression sine to the -1 there, that is what is the inverse sine. It is not the same as a reciprocal. So like, sometimes if I would have seen, 1/2 to the -1, we would think that that's really like flip the fraction over 2 over 1 to the first. So you're not flipping this. So if we had sine inverse of an angle, that is not the same as 1 over sine of the angle. When we take a look at the inverses of trig functions, we're going to find out that these are not functions themselves. So when I say functions themselves, that means that they would not pass the vertical line test. So they would fail that. They would have, in this case, they'd have more than one x, or more than one y for each x, when we kind of figure out what this is. Again, that's going to happen because for a certain angle, when we are finding the values, there are going to be many values of an angle that would have a specific value for a. So for example, if I said I wanted to find cosine inverse of 1/2, again, what this is really asking me, what angle measures have a cosine, or we know that when we talk about cosine of an angle, we're really talking about the x-coordinate. So what angles have the x-coordinate of 1/2? Well, on our unit circle, we can see already that that's two places, pi over 3, but also 5 pi over 3. So again, that x-coordinate was 1/2, and this x-coordinate over here is equal to 1/2. So since there's more than one answer, then that cannot be a function itself. Also, if you wrapped around that circle many times, we talked about doing like repeated, go 360 degrees or 2 pi around, you would land with coterminal angles in the same spot. All of those would also have that same cosine. So we're just looking for all of the places where that's going to happen.
Okay, so let's take a look at our first example. We are finding trig inverses. So find all possible values of cosine inverse of 3/2. Again, remember the translation of this means find angles whose cosine is square root of 3 over 2. So we are looking on our unit circle for, it's kind of like a little scavenger hunt, looking for where on the unit circle is the x-coordinate going to be square root of 3 over 2. I found one there, and I found one here. I don't see any others for the x, because over here that's going to be negative. We don't want that. That one's negative. We don't want those. So let's go with the two that we have. Okay, and so the two that we have are going to be 30 degrees and 315 degrees, or in terms of radians, that would be pi over 6, not 315, because Bella's correcting me. 330 degrees, okay, pi over 6, and that's also 11 pi over 6. So those would be two of the many answers that we could put down for what angles have a cosine of square root of 3 over 2.
All right, let's look at our next one, kind of the same idea here. I want to find all possible values of tangent inverse of 1. So again, that means I want to think about tangent of what angle. So what angle could I put right here? So if I take the tangent of it, it is equal to 1. So again, I'm going to find angles, I'm just going to use theta there, angles whose tangent equals 1. Now, if you remember how we found tangent, tangent is really by taking the y-coordinate divided by the x coordinate. So if I look on my unit circle, I want to look for something that would reduce to 1. Well, if I'm going to get this to reduce to 1, what must be true about my x coordinate and my y coordinate? Well, if it's going to reduce to 1, they must be the same on top and bottom. This is also a positive 1, so my x and y coordinate must have this not only the same like value, but also the same sign. So looking around my unit circle, I see a pair here, square root of 2 over 2, comma, square root of 2 over 2. And, okay, this one looks like it might fit, but I noticed that I have one positive, one negative, so I'm going to rule that one out. Right, that'd be negative 1 if that was our choice here. Down here in quadrant 3, I see another pair that's exactly the same sign. And again, quadrant 4 almost gets me there, but I have a negative there, so I don't want to rule that one out. So I'm going to be using the values, not the values there, the values here and the values here, which happen at those pi over 4 markings. So some answers that my theta could be are going to be pi over pi over 4. It's okay, pi over 4, which was the same as 45 degrees, or 5 pi over 4, which would be equivalent to 225 degrees. And, you know, as we mentioned before, those are just a few of the answers. Remember, we talked about coterminals, so you could keep wrapping around the circle, and, you know, I can add 360 degrees to this and go around the circle again, and another answer here could be 405 degrees. That would also have a tangent of 1. Okay, there are many, many answers. We're just listing the ones we see on the unit circle right now.
Okay, so because more than one value of theta produces the same output value for a given trig function, it is necessary to restrict the domain of each trig function in order to define the inverse trig function. So if we actually want it to be, if we actually want the inverse to be a function, we're going to have to limit the domain so that we don't have multiple answers. We only want to have one answer possible, and we want to agree on what that one answer is going to be. So trig functions with restricted domains are indicated with a capital letter. The domains of capital sine, capital cosine, and capital tangent are restricted as follows. So for capital sine, it's going to be regular sine, except we're only going to be looking at the angle theta between negative pi over 2 and pi over 2. Well, you know negative pi over 2 is here on our unit circle, and pi over 2 is here. That means we're only looking to find our answer on the right side of the unit circle. So here's 0. We can go from 0 up to pi over 2, or 0 down to negative pi over 2. And then for capital cosine is the cosine of theta, but the theta has to be between 0 and pi. Well, you know that 0 is here on the unit circle, pi is here, so we're restricted to looking only on the top half of our unit circle between 0 and pi. And then for capital tangent function, so that we only get one possible answer for that, then we would want to say tangent has to be between negative pi over 2 and pi over 2. And again, that's from here up to here, so that's the right half of the unit circle. The only difference here is that we are not including, right, this is strictly less than, we're not including the negative pi over 2 or pi over 2, because if you remember, tangent of pi over 2 is going to be the y over the x, and that ordered pair up here, 0, comma 1, would be 1 over 0. That's undefined, so that's why we don't include the negative pi over 2 or the pi over 2.
So these functions can be used to define the inverse trig function. So each value of a in the domain of the inverse trig function, there's only going to be one value of theta. So again, we're only going to be finding one angle now that matches that. So therefore, even though tangent inverse, again with a lowercase here, okay, has many values, so I can find a lot of places on the unit circle. If I'm doing capital T tangent inverse of 1, so really I guess that's the example we did before, tangent inverse of 1. That had lots of answers. Capital tangent inverse of 1 will only have one value because we're going to restrict, we just looked on the last page, tangent inverse is only going to be which of those values would fall on this right hand of the circle between negative pi over 2 to positive pi over 2. So again, just a recap of what Mrs. Pesic said on the last page. In words, if I have inverse sine function, again, I'm talking about that's the function now. So that is the capital letter S with sine inverse. That's where does the sine of your angle equal that value? I'm going to be looking between, my angle is going to be in between that negative pi over 2 to positive pi over 2. So any time I do an inverse sine, I'm going to look on the right-hand side of the circle between negative pi over 2 to positive to find that. If I'm looking for the inverse cosine function, again, a capital S here, or sorry, capital C, that restriction, my angle measure, again, so I'm worried about my angle measure is between 0 or pi. And if you notice, underneath each of these, it's giving you the equivalent in degrees. So cosine is the top half of the circle, and then again, the inverse tangent function with a capital T, that restriction is negative pi over 2 to pi over 2, or negative 90 to 90. So when we are taking a look at that, we're going to keep that in mind when we want to solve these. You can also call them arc sine, arc cosine, and arc tangent as another way to refer to those. So let's look at our example 2 here and actually try to do one of these. I want to evaluate each inverse trig function. We're going to give an answer in both radian and degrees. I notice right away that I have a capital letter C, so it must be a function, which means I only want one answer. Since it is cosine, the inverse of cosine here, I'm only going to look between 0 and pi, so only on the top half of my unit circle. So I'm only going to look in the values here between 0 and pi. So where do I have an angle whose cosine is going to be negative square root of 3 over 2? So again, I'm looking for an angle whose cosine is negative square root of 3 over 2, or that means the x value is negative square root of 3 over 2. So taking a look here, I'm going to see that my x value, again, if I check all my x values here, I find out that right here, there's that x value that I'm looking for. So what angle was that in radian and in degrees? Well, in this case, my original problem here, cosine inverse of negative square root of 3 over 2, capital C, is equal to 5 pi over 6, or 150 degrees. That'd be the one place, so I'm not going to look anywhere else on the circle for that answer.
So 7 pi over 6 would have been an acceptable answer if you had a lower case c, but since you got a capital C, we've got to strictly stick with numbers between 0 and pi. All right, let's try another one. Evaluate capital sine inverse of negative square root of 2 over 2. So again, what this means is you are looking for, basically this is saying find the angle, and the angle has to be between negative pi over 2 and pi over 2, which has a sine of negative square root of 2 over 2. So when you see this with a capital S, sine inverse, that's what this means. Find the angle between negative pi over 2 and pi over 2, which has an angle of negative square root of 2 over 2. So we are restricted to looking right here on the unit circle for capital sine inverse, and we're looking for where is the sine equal to negative square root of 2 over 2. So we're looking for the y. I think I found it. All right, right here, because this y coordinate is negative square root of 2 over 2 here, and it's the only place. So our answer is going to be 7 pi over 4, or 315. No?
Well, could we make it negative?
Oh man, too bad. So we found it on the unit circle, but this is what we need to do. We need to really think about what about going in this direction. This is going to be negative pi over 6 here. This is negative pi over 4 here. This is negative pi over 3 here. So 7 pi over 4 would not be a good answer for this problem. The answer for this problem is going to be negative 1 pi over 4, or we could say negative 45 degrees. All right, so that is the only acceptable answer for this problem.
So here's a must do for you. We're looking for capital C cosine inverse of 0. So again, look at your restriction for cosine. Cosine is the one, again, that is the top half of the circle, so from 0 to pi. So where on this top half of the circle do you find that the cosine is equal to 0? So where is the x coordinate equal to 0? Again, since it's the capital letter here, only provide one answer for that. Okay, let's look at an application problem here. So a painter needs to lean a 30-foot ladder against a wall. The safety guidelines recommend that the distance between the base of the ladder and the wall should be 1/4 of the length of the ladder. So to the nearest degree, what acute angle should the ladder make with the ground? Well, we're using trigonometry, so we know that everything we set up here, if we have to kind of model it, is going to be based on a right triangle. So I want to draw that first. The painter is leaning a 30-foot ladder against a wall. So the ladder that he's leaning must be right here, or my hypotenuse of this triangle. And we know that that measure is 30 feet. Now, it also says that because of the safety guidelines, the distance between the base of the ladder and the wall is going to be 1/4 the length of the ladder. So I need to figure out what is 1/4 of 30 feet. So whenever I have the word of, remember that's a multiplication. So really I need to do 1/4 times 30 to see what that would be. So use your calculator if you need to, but this is 7.5 feet. Now, 7.5 is going to represent the distance between where the ladder's, foot is down on the ground to where the wall is. So that is going to be this side. It's not up the wall, it's along the floor, 7.5 feet. Our question here is, what angle should the ladder make with the ground? So we are looking for, between our ladder and the ground, we're looking for this angle right there. So there's my theta. So based on what we know about SOHCAHTOA and right triangles, what are we given so far? Well, across from the 90 we have our hypotenuse. And since the 7.5 is making a side of this angle, that is the adjacent side. So remembering what we did a couple lessons ago about SOHCAHTOA, in this case, we have adjacent and hypotenuse, so it looks like cosine is what we're going to want to set up in this case. So we're going to say, okay, well, the cosine of my angle, which I don't know, so I'll just put theta there, is equal to what? Well, A over H, so 7.5 divided by 30. Now, previously we just said, okay, that's good enough, just kind of leave it set up like that. But now we know about inverse trig functions. So now we actually can find what our angle measure is. So if I want to solve for what this angle is, I need to somehow deal with this cosine that is here. And the way that we will do that is we're actually going to do the inverse. So we're going to say, okay, the angle that would provide this answer must be cosine inverse of 7.5 over 30. So it's kind of the inverse operation. Like instead of multiplying, you divide. If you have a cosine to solve it, you take the cosine inverse. So we'll need our calculator to help us here. So on our calculator, we're going to go over to that. And to find cosine inverse, it's with the trig. You'll notice right there, cosine inverse, and then you'll type in what we had. So 7.5. And we had an fraction, so 7.5 divided by 30. And we will find out in this case that that is equal to 1.31. Right, remember our calculator is set in radian mode. So if I want to now say, well, that's not really degrees for a triangle, my conversion between radians and degrees is going to be multiply this by 180 divided by pi. So you'll need to do that calculation before you can answer this question. You have to change it to the right type of unit. So that is, it'll say 75.5 degrees for our angle. So theta here must be 75.5 degrees. So again, don't forget to convert from radians to degrees. So your angle shouldn't have that big of a measure. So here's your second must do. Same idea, draw yourself a triangle. You're going 1 mile east and 0.75 miles north, and you're going to figure out what should be your direction, your angle there, that you go from the lake to the rock formation. So maybe just to help you out here a little bit, if I think about my right triangle, in this case we know we're going from a lake, here's my lake, kind of looks like a cloud, up to a rock formation. I don't know how to draw a rock. There's my rock. All right, and we're going 1 mile east, so going this way east is 1 mile. And then we know that they are going to go north 0.75 miles. And your goal is to figure out what direction they should head from the lake to reach the rock formation. So what would my angle right here be?
They want to walk directly to the rock. They don't want to walk 1 mile east and then 0.75 miles north. They want to go straight there.
Yeah, they don't want to take that big shortcut.
Okay, so they got to find that angle that they should be traveling. All right, that's your notes must do number 2. And oh, there's more. Wait, there's more. Okay, let's take a look at this. Solving trig equations. Solve each equation to the nearest tenth. Use the given restrictions. So in this case, we want to find sine of theta equals 0.4. and we want our answer to be between negative 90 degrees and 90 degrees. So really, think about this as theta, our answer, is going to be the sine inverse of 0.4, all right? But again, since we want the angle to be between negative 90 degrees and 90 degrees, that's going to be the only answer possible. So let's try this on our calculator. We go to trig, sine inverse of 0.4, and we end up getting 0.411, but that is in radians, so I need to convert that to degrees, so I multiply by 180 and divide by pi. And when I do that, I end up getting 23.6 approximately for our answer. What did I say? 23.6 degrees. All right, that brings up notes must do number 3. Solve the equation tangent theta equals -2, and you want your answer to be between -90 and 90. Notice up here we were including the -90 and 90, and here we're not including. We know our answer could not be -90 or 90 because tangent of 90, for example, is undefined. So you're going to try this one, use your calculator, and do that. All right, that's it for this video, and hope you took good notes and did your notes must do's, and we'll see you next time.
Thanks for watching.